Welcome to my channel called with Fernando. In this one, I'm going to start a new series of videos. It will be all about reactive programming. So, what skills do you need before going to this series of videos? You need to have a basic Java knowledge. You need to understand what the most important features of Java 8, like lambda expression, streams. You need to understand what object-oriented programming is. Most important, what is a class, what is an interface, and some design principles. You need to understand multi-threading concepts. What is a thread? What is concurrency? Okay, and you need to be able to work with Maven or Gradle. In this one, I will be working with Maven, but you will also be able to use Gradle if you want. I will be using Tele ID. Of course, you can use whatever ID you want, like Eclipse. By the end of this phase, you should and you will be able to understand what reactive programming is and when to apply it. You will be able to implement basic reactive streams components manually. You will know how data flows through a reactive pipeline, including how demand and errors are managed. You will be ready to move to real-world implementation with Project Reactor. Okay, so I have divided this phase. I have divided phase 1 into modules. I have already created 4 to 5 modules. This is module 1, Introduction to Reactive Thinking. So, in today's digital world, users expect applications to be fast, responsive, and scalable. Traditional programming models often rely on blocking operations and multiple threads, which can lead to poor performance when dealing with many users of large volume of data. On the other hand, we have reactive programming. It offers a new way to build applications that are event-driven, asynchronous, and non-blocking by design. These concepts are really important: event-driven, asynchronous, and non-blocking. So what are the benefits of with working with reactive programming? Response to events and data as they happen. Okay, it handles concurrent tasks with fewer system resources, improves scalability and performance. It's well designed for real-time data-intensive applications. What is reactive programming? Okay, reactive programming is a style of coding that works with data streams and events. These streams send values over time, like clicks, messages, on or sends of data. Also, for example, HTTP requests, often in unpredictable ways. So, what are some key concepts with this? It works with asynchronous data streams. Values can arrive at any time in any order. Designed for real-time event-driven systems. Replaces step-by-step logic with data flow rules. Okay, more or less this is the main concept behind that. Instead of telling the computer exactly what to do, you define how data should flow and how to react when something happens. Okay, this is a reactive style. When new data arrives, transform it. If there is an error, handle it with gracefully. Code responds to changes after they happen. It makes an app more flexible, scalable, and responsive. What are some core traits of reactive programming? Okay, we have reactive programming bring powerful features that help you write efficient, responsive, and scalable applications. Okay, these traits are asynchronous and non-blocking. Okay, code runs in the background without blocking threads. Okay, what's a thread, by the way? A thread is a unit of execution. Don't forget that. What's a thread? A thread is a unit of execution. The app keeps working while waiting for data, for example, like network or file access. Back pressure aware. System paths communicate how much data they can handle, prevent overload, and ensure smooth data flow. I have already written an article about back pressure. We are also going to make a complete video about back pressure. So if you find this concept kind of confusing, it's okay, don't worry. I'm going to talk about this in great detail later. Okay, we have part 2. Let's continue. Composability. Easily combine, filter, and transform data streams. We can use a lot of operators. Filter, mapping, more of these operators look like the ones that we use in Java 8, for example. So if you know Java 8, you will be really comfortable with working with these operators also. It leads to more readable and reusable code. Resilience. Errors are detected and handled in the stream. Systems can recover or pass error downstream from handling. Okay, we have reactive, imperative, and asynchronous programming. We have three type of programming, let's say like that. Okay, let's look at three different ways to write code. Imperative, the one that we most of the time we use. Imperative will tell the computer what to do. Okay, you have asynchronous and reactive at the end. Each has its own strength and trade-off. Always like more computer science concept, there is always a trade-off. Okay, let's begin by imperative programming. It's a traditional step-by-step instructions. Code runs in order, one task at a time. Simple and easy to follow. Okay. Then we have asynchronous programming. Tasks running in the background. You get the results later using callbacks or future. Non-blocking. Okay, this is important. This is non-blocking. Okay, can we have to manage with nested callbacks, or what do we also call callback hell. Then we have reactive programming. Okay, we can say that reactive programming takes asynchronous code to the next level. It gives you powerful tools to work with data streams, events, and errors in a clean and efficient way. Okay, so what are some of the keys concepts of reactive programming? It's fully non-blocking. This is really important. Non-blocking and event-driven. It handles data as streams, values, errors, and completion. It supports back pressure. Okay, that is the second time that we see with this concept, back pressure. Okay, it offer back pressure out of the box to manage flow and prevent overload. Streams can be filtered, combined, transformed, and reused. This is ideal for responsive, resilient, and scalable applications. Like I told you before, I created an article. In the middle of this article, you will be able to find a code demonstration. It's a simple code demonstration of how the imperative approach and the reactive approach. This code is about books. Okay, let's continue. Let's go to our IntelliJ. Let's create a class called book. This class has a private string, and let's call this title. Private string. Let's call this genre, because we are going to filter the book by genre. Then create a constructor. Okay, after that, let's create our getter methods. Getter for both of them. I think for what's just one if enough, but it's okay. Then create our string method. Okay, that's it. Then create another class. This class will be called imperative book processor. Imperative book processor. Okay, this class will have two static methods. The first one will be called public static method. This class will take up list of books and will return a list of books also. Okay, let's call this class filter books by genre. Okay, this class takes a list of books. Let's call this books. Then we need the genre, right? The one we are going to filter. Okay. So what do we do first? Let's create a container. Container of books. Okay. So list of books, and let's call this filter. Filtered. Okay. The new array list. Okay. After that, let's iterate. So this is a type of book. Call this book. Iterate over books. So I know that we can use these methods from Java 8, filter, map, reduce, all of those amazing methods, but I don't want to use them. Later you will see why. What's the reason though? So now, book, get title, no, get genre, okay, equals in our case, genre. Okay, so if the title of the books is equal to this one, okay, only that case we are going to add this book to our filter. Only that condition. Okay, and finally we are going to return a filter. We're going to return these books. Okay, let's finish. Okay, now let's create another method, another static method. Static method, let's call this method will be a list of strings. And let's call this method transform titles to uppercase. To upper. Okay, this takes a list of books also. A list of books. Okay, what are we doing here? Let's create a container of type strings, of type string. Let's call this titles, new array list. So now let's iterate over books. So let's, this is book. Let's iterate over books. Okay, I'm sorry. So now in titles, we are going to add book title to uppercase. Okay, that's it. And finally, we are going to return titles. Finish. Now let's create our main method. Our main method is our entry point. Okay, that's why we have our static void main method. Okay, in our main method, what do we have? Let's, I'm gonna take from here the list of books. I don't want you to see me typing this. This is no, it's not necessary. Okay, just list. Okay, what do we do first? We want only fantasy books. Okay, so if we want only fantasy books, what do we do? Let's create a container. Okay, another container of type book. Let's call this fantasy book. Fantasy books. Okay, this, how do we call this? Because this is a static method, so we need to call the class first. Imperative filter books. Okay, and now we pass the books and then a string. In this case will be fantasy. Fantasy. Okay. Then what do we have? Let's create another container of type. No, it will be type string. Okay, it's container type string upper titles. Remember the static method that we have. So upper pretty book transform. It takes only fantasy books. So what are we doing here? We are filtering by fantasy. So we have only this book and this other one. Okay. After that, we are going to we have taken the titles and we are uppercasing those titles. Okay. So now we are going to print those titles. This is type string title upper titles. Now we are going to print the title. Simple as that. Okay, let's run this. Okay, this is quite easy. This is just a demonstration. This is the iterative approach. This is what we always use. Okay, iterative approach will tell the computer what to do and when to do. We give orders, we give steps. So now let's continue with the reactive approach. That's why I created this class called reactive book processor. So in this class, I will create a class, a method, sorry, a static method also, will be flux. Okay, now you might be asking, hey Fernando, you haven't told us anything about flux. What is flux? Okay, I promise you, within one or two more videos, you will be able to understand flux, more not all of those. I just want to show you what is what is the reactive approach. That's it. Get books stream. Okay, now we are going to return flux. Just Okay, I'm gonna take the information from here. I have 4 books already. So I'm gonna copy in here. That's it. Okay, and now we are going to simulate something here. We are going to subscribe because in reactive programming, nothing happens unless you subscribe. Okay, now sketchers. What is this? Okay, now this bone elastic. Okay, that's all we need for now. Now let's continue with our main method. In our main method, we are gonna call this. Let me comment this. We don't need this anymore. Just going to comment. Okay. Now let's see the reactive approach. That's why. Because it's a static method, we need to get book string. Then what do we do here? Okay, we are going to do the same. We are going to filter by genre. In this case will be fantasy. Then we are going to take the title and we are going to uppercase those titles. Okay, so basically we are going to do the same by using reactive approach and some amazing methods. Okay, filter. That one is kind of similar that we use in Java 8 also. Okay, this book genre equals uh, equals in our case, in this case will be fantasy. Okay, because we want to filter only the fantasy books. Then map. Okay, we are going to map. We're going to create a new book in here. Okay, we need a book title, the title, and also this book. We are going to uppercase that. Okay, then what is asking for the book? Get genre. That's it. So we are creating a new book, but this book is filtered. It's first only fantasy books, and then we are getting the title. We're uppercasing those titles. Okay. Then what do we do? So there's some amazing methods on Java on reactive programming. Do on next. Okay. It's going to print here processing book. I know these methods we haven't know anything about what is do on next, what is flags, what is map, filter. I promise you, we are going to see these methods, all these concepts in one or two more videos. I just want to show you what is this about. I'll do on error. Error. Okay, in here we're going to print an error. Just simple as that. An error. Just going to print error. Error. Now what do we do? Do on complete. As soon as it finishes, just do something. Okay. Let's print here processing completed. Complete. Okay. Finally, subscribe. Because nothing happens if you don't subscribe. Okay. Then we are going to simulate something, a thread or sleep. Okay, let's see. Okay. Okay, it's okay. Exception. Let's print this. We are taking a book. Now we are printing that book. It's here, processing book. Okay, finally, processing complete. It is just a demonstration. Just a demonstration. We are going to go in great detail. We are going to understand what is flex, what is mono, what those methods come from, all of this. Okay, thank you. Okay, let's continue with the reactive manifesto. Every reactive application should follow these concepts. Okay, responsiveness. A system should respond quickly and consistently. A slow system feel broken even if they still work. A reactive system aim to give fast feedback even under heavy load. Resilience. When something goes wrong, like a service crash, the system should keep working. Reactive systems handle failures by recovering or switching to backup paths without breaking the whole system. This is a very important concept in computer science in general. Resilience. Elasticity. Systems should be able to scale up or down based on demand. If the traffic grows, it should use more resources. If traffic drops, it should use less. This helps save costs and keep performance stable. Finally, at the end, we have message driven. Reactive systems use asynchronous message to talk between components. This creates loose coupling. What is loose coupling? Loose coupling is a design principle that reduces the dependency between components. Again, loose coupling is a design principle that reduces the dependency between components. So, okay, this creates loose coupling. Part of the system don't need to wait for each other. Messages can be buffered, retried, and routed, making communication more reliable. Summary. This is what we have learned. Okay, the difference between imperative, asynchronous, and reactive programming styles. How the reactive manifesto helps guide the design of responsive, resilient, and scalable systems. How to build a reactive data processing pipeline using Project Reactor. Okay, the real-world benefits of reactive programming, such as non-blocking I/O, composability, and back pressure control. Thank you so much. I forgot to tell you guys, I already created an article, a Medium article, in which you can find a very detailed explanation. So if you are more like a person who loves to read more than watching videos, so this is the best chance for you. In here you will have a very detailed and deep explanation of all the concepts that I just explained. So I have already created this one is for you guys. You can find the code that we just saw before, and also you will be able to find the link in the description. Okay, so give us a like and subscribe. Bye.